All right, we've made it. We can do this. So the last thing we're going to do is stoichiometry with limiting reagents. Now, it's been a long time since we did any of these, but we got this. First question. What mass of potassium chloride forms when 5.25 liters of chlorine gas at 0.950 atmospheres and 293 kelvins reacts with 17 grams of potassium? So the first thing we have to do is come up with the formula. So we have potassium chloride forming by the reaction of chlorine gas and potassium. Now, what's the only thing that you need to remember? When we have a gas or anything that is diatomic, like a chlorine, you need a sub 2. Okay, and then you got to make sure you balance the equation. Because we had to do Cl2, we need to have a 2 in front of my potassium chloride, so then I have to put a 2 in front of my potassium. Okay, then let's line up the information we know. We want to know what mass of potassium chloride forms. So we want to know the mass of potassium chloride that's forming when 5.25 liters of chlorine gas, so the volume of chlorine gas is 5.25 liters, at a pressure of 0.950 atmospheres and a temperature of 293 kelvins, reacts with 17 grams of potassium. So the difference between these questions and the questions that we did before is that they've given you information about both of your reactants, chlorine and potassium. So we need to start with figuring out which of these is limiting the reaction so that we can figure out what mass of potassium chloride will actually be found. So let's start with the chlorine. So for the chlorine, we have volume, pressure, and temperature. And the rule is if you have 3, you can find a 4th. So we're going to find the moles of chlorine, just like we are also going to find the moles of potassium. Now, when I'm doing limiting reagent problems, it's funny, when I was doing the review chapter, I did them differently based off of what another instructor did. But then I came to doing these and I went back to the way that I've always done it. So there are multiple methods of figuring out what the limiting reagent is, and it really comes down to personal preference. I'll try to talk about the 3 different methods that I know of, but I'm going to start with the one that I like to do. So what we're trying to do is produce potassium chloride. And for me, the easiest thing to do is to say, okay, well, I have so much chlorine. How much potassium chloride could that produce? And then I do the same thing with potassium, and whichever one produces less, well, that's the most that you can make. So let's start with finding the moles of chloride. So again, we've got PV equals nRT. And so we're going to solve for N by doing PV divided by RT. So my pressure is 0.950 atmospheres. I don't need to put my units into my equation. My volume is 5.25 liters. My R value is a given, 0.08206. And my temperature is in kelvins, so I can put it straight in. So this is going to be the the moles of chlorine that I have. So I'm going to get this answer. I'm going to go 0.95 times 5.25 divided by 0.08206, and then I go divided by 293. But you're more than welcome to go bracket and multiply between. But I get I'm going to keep track of sig figs, 0.207 ... moles of chlorine. That's how much I have. Let's do the same thing for potassium. So potassium, instead of them giving me PV equals nRT, they're giving me the mass. So I'm going to start with 17 grams of potassium, and I'm going to convert that into moles. So 1 mole of potassium weighs, where did I put my formula sheet again? Potassium, 39.10 grams per mole. So then I'm going to type this into my calculator. So I've got the other number and I've stored it as A, because I'm going to have to clear my calculator. And then I'm going to take this one. So 17 divided by 39.1, and I end up with 0.434, I'm not rounding, moles of potassium. Moles of chloride. Okay. If you were watching the videos at the beginning of the semester, and maybe I've changed them by now, but if you're watching them the way that I did it one way, so some instructors, what they like to do is go, okay, well, let's compare these two. So let's convert from moles of chloride into moles of potassium, or moles of potassium into moles of chloride. That's a great way to do it. If you're coming from Chem 50, you might say, well, how many reactions would this be allowed to happen? So you could divide this guy by 1, you could divide this guy by 2, and you could realize that this amount is less, so chloride is the limiter. But I've come to a place where I'm like, you know what? Let's just find how many moles of potassium chloride it produces, because that's the one thing that I have to do anyway. So for example, here, I know that 2 moles of potassium will produce 2 moles of potassium chloride. So this would produce 0.434 moles of potassium chloride. And if I do the same thing for this guy, I know that 1 mole of chloride produces 2 moles of potassium chloride. Then I'm going to multiply that one by 2. So I'm going to take my recall A times by 2, and I end up with 0.414 moles of potassium chloride. So I have to do that anyway. I have to get to a place where I know the moles of potassium chloride. So if I just take them both to moles, and then I can recognize that the chloride produces less moles of potassium chloride, which means that it limits the reaction because it can only produce 0.414, whereas we have enough potassium to produce 0.434. And the nice thing about that is now all we have to do is say, okay, I've got 0.414 ... moles of potassium chloride, and I want to know how much that's going to weigh. So 1 mole of potassium chloride weighs, so we already know that the chloride is 39.10. We know that the chloride is 35.45. So I'm going to store as A. 39.1 plus 35.45 gives me 74.55 grams. So I'm going to take that number and multiply it by my recall A, and I get to 3 sig figs 30.9 grams of potassium chloride produced. Now again, I took these to moles and stopped. Some people take it all the way to grams and then be like, oh, that one's less and I'm done. But you can kind of make it your own. So again, no one method. So this is the way that, you know, after trying the other way, and I've tried other people's ways, this is the way that I love. Just go all the way to what you want, and whatever one produces less, that's your limiter, and then convert those moles into grams in the end. Okay, so there's one more. If you feel like you're ready, pause the video and give this one a go. Otherwise, I'm going to work it through with you. So we have a sample of 26.81 milliliters of 0.1 molar hydrochloric acid reacting with a rock containing calcium carbonate. What would be the maximum theoretical volume of carbon dioxide collected? So that's what's going to be produced. And you're also going to produce water and calcium chloride. So we've got hydrochloric acid reacting with calcium carbonate to produce carbon dioxide and water and calcium chloride. First thing you want to do is make sure that your equation is balanced. I can see right off the bat because I have 2 Cl's on the left, and 1 Cl on the left and 2 on the right that I'm not balanced. I always do a quick check of my oxygens. So 3 oxygens on the left and 1, 2, 3 on the right. So let's just balance these chlorides. So I'm going to put a 2 here on the left, and then I have 2 HCl. So I have 2 H's, 2 H's, 2 Cl's, 2 Cl's, 1 Ca, 1 Ca, 1 C, 1 C, 3 O's, 3 O's. Okay, awesome. And then I like to put in what I know. So I know the volume of hydrochloric acid is 0.02681. We want everything to be in liters. But they've given us a molarity of 0.1000, right? And remember, that's moles per liter. They've given us the mass of the rock, so 3.164 grams of calcium carbonate. And we want to know the volume of carbon dioxide produced at a temperature of 30 plus 273.15. So 300.15. They put the decimal place at the end of the 30, so this is going to be 3 sig figs, and a pressure of 1 atmosphere. You need to know 3 pieces of information to solve for the fourth. So we need to find the moles of carbon dioxide so that we can find the volume of carbon dioxide produced. How are we going to do that? Well, let's figure out who's my limiter. So when we start with the hydrochloric acid, they've given me molarity and volume. So moles of hydrochloric acid is going to equal molarity times volume. So that 0.1000 moles per liter times the liters gives me 0.002681 moles of hydrochloric acid. Now again, you can stop there and then you can do the moles of calcium carbonate and then compare the two using, Marianne's method of dividing by the coefficient or converting one into the other. I know that I'm going to right away go to moles of carbon dioxide produced. So I know that 1 mole of carbon dioxide is produced for every 2 moles of hydrochloric acid consumed. So I know that this would give me 0.1 times 0.02681 divided by 2 gives me 0.0013405 moles of carbon dioxide produced. And then let's compare that to calcium carbonate. And again, you can use whatever method you want. So I've got 3.164 grams of calcium carbonate that I'm going to change into moles. And then because I know I'm going to go all the way to moles of calcium chloride or carbon dioxide, sorry, that was the last question, I'm going to put another line. So I'm going to say that 1 mole of calcium carbonate, actually, no, I shouldn't. Just in case you guys are another method, it's nice to have some things to check. Okay, so let's just do that. So calcium carbonate is 1 calcium, what is that, 22.99? Nope, 40.08. Calcium is, or carbon is 12.01 and 3 oxygens. Okay, so store A. I'm going to do this guy, so 40.08 plus 12.01 plus 3 times 16 gives me a molar mass of 100.09 grams. So that's going to give me 3.164 divided by 100.09 gives me 0.03161 moles of calcium carbonate. And then I'm going to change that into moles of carbon dioxide. And again, I could have done that in one step, but 1 mole of calcium carbonate produces 1 mole of carbon dioxide. So it's a 1-to-1 ratio. So this would produce 0.03161 ... moles of carbon dioxide. Then I check which one's less. Well, this is way more than this guy. So I'm going to say that the hydrochloric acid is my limiter. And so I'm going to use this as my moles of carbon dioxide. So let's make sure I kept track of sig figs there. So it was 4 times 4. So this would be 4 sig figs. So 1, 2, 3, 4. Okay. So I'm going to put in for moles 0.001340 ... moles of carbon dioxide. So then my last thing is to use PV equals nRT to solve for V. So nRT divided by P. So my moles is that answer that I just got. So that 0.001340 ... My R value is 0.08206. My temperature is 300.15, but that's only 3 sig figs. And then my pressure is also 3 sig figs. Okay, so then plugging all of this into my calculator, I'm going to go recall A. And I'm going to times that by 0.08206 times by 300.15 divided by 1, which I don't really have to do. And I end up with 0.0330 liters, which in the question it gave it to you a bunch of stuff in milliliters. This is a great answer. You can give 0.0300 liters if you want, or you can convert that to milliliters if you're of that persuasion, and you can say 33.0 milliliters because it's kind of a nicer number. Yay! Okay, hopefully gas laws feels good. Go and practice these questions.